Hello, good afternoon, students. This is Dr. Sushree Samikhya Pattanaik. I welcome you all to the control system class. Today, we are going to discuss regarding introduction to control systems, some concept of control systems, types, applications, and we will discuss regarding open loop control systems and what is the difference between open loop as well as closed loop control systems. Okay, so here I will give you one basic example for a system. Basically, system consists of so many interdependent components, and from these components we will get one output basically. We will take one example of our institute. So institute's aim is to produce engineers. Basically, institute consists of so many departments interdependent on each other. Another, there are so many cells, faculties, but the major aim, the input will be our students and the output will be our engineers. So here by taking one example, we will see what is system actually. So in this diagram or in this image, we can see that one tap is there, another water tank is there. So Q in means this is your flow of water to the tank from the tap. Another Q out means this is the flow of water from the tap. There are two parameters we have taken. One is capital S, another is small s. Capital S is our reference point, small s is your control variables. So here there are three conditions we will get. Q out means this is a flow of water from the tank, basically depends upon the control variable, that is our small s. Here Q out will be equal to Q in when H is constant. Another, if Q out is greater than Q in, then tank will empty. Another, Q out is lesser than Q in, then tank will be overflow. So this is a system. We have taken the water level condition and by setting two parameters, one is reference, another is control variables. So if we take one example of our control systems, best will be our one fan is there, from where we are getting our speed. Another fan is there, we are putting one regulator. So one fan without regulator, that is not in our control. But here if we take one regulator with the fan, we can say that this is a control system. That means by varying the regulator, we can increase or decrease the speed actually. There are so many examples we will take for our control systems, that is our heating and cooling homes and offices. Another, automatic cruise control, hold the position of a mechanical linkage. Another is maintain level of a water tank. So many nowadays we are dealing like our ACs, toasters, normal irons. These are the example of our control systems. Let's move to the next slide. So what are the basics of system of our control systems? Basically, we are dividing into three parts. One is measurement, another is control decision, another is system modification. So in previous diagram, if we will compare with this diagram, only difference is that one valve is present and one human is there. In previous diagram, we cannot control the water flow from the tank, but here if you see that valve is there, we can control the flow of water from the tank by adjustment of the valve. That decision will be taken by our human. So here we can say H is the reference point, same as, and small h is the control variable. Here small s is the process to maintain the level of the tank, and here measurement slide gas means here by through which we can see the level of the water inside our tank. Another control decision, which is the major one, that will be done by the human. Here we can see that human adjust the flow of water from the tank to maintain small h will be equal to capital H, and the final element valve control the flow of water from the tank. Okay, so another terms is there, that is our automatic control systems. Nowadays, we all are familiar with our automatic terms. Automatic means there will be no human interference. It will be done by sensor and other systems basically. So here, if we compare previous two diagrams, we can see that rather than taking the human interference, the valve will be sensed and controlled by the sensors. So everything is same. We can see we are having one sensor, another is controller, another is final element is there. Our major aim is to control the flow of water from the tank. What are the elements of our automatic control? First one is process. So process means it may be deal single or multiple variables. Measurement. Measurement means it will be done by the sensor whether the water should be present inside or outside. Next one is error detection. Means if there will be any difference between small h and capital H, what will be the required value and what will be the set value. So here another controller means it will generate the correctness if any variation between measurement and actual value will be there. Next one, final controller element means it will modify the process. So there are three systems we have seen. First one without valve, second one with valve and human interference. In third one, valve with sensor. So this is the advanced version of our control systems. We can see that. So next we will discuss regarding block diagrams and how we will represent our control systems. So we can see that there are basically three things is there. So we are taking control system components. Inside it there are many different or interrelated components are there. Input will be our input signal and output will be our output signal. Again we have taken one energy sources which is optional one. So this is the representation of block diagram for any systems. So we can see that control system means we will give some input to a system and from where we will get the output. If it is a control system, then output will be the desired one. If it is not control system, then any types of output we will get it. So signal flow between component in the system basically based on the arrow marks of the directions. Now we will take different types of typical component of block diagrams. So let's first one we will take the temperature sensors. So what is temperature sensors? Input will be our temperature which is in terms of degree Celsius. Our major aim or ultimate we are getting our output which is equal to V output in terms of millivolt. Again another systems we are taking that is our amplifier. Amplifier means it will amplify the voltage. So we are taking V in terms of V. Again we are getting our V output in terms of V also. Next one we have taken another systems that is our DC motor. Here input will be armature voltage and we are getting our speed which is in terms of RPM. Another systems we are taking that is our control valve. Input will be your valve position which is in terms of percentage open. Depending upon that we are getting our output which is liquid flow in terms of meter cube per second. Another we have taken that is our transmitter. The signal will be coming to our level transmitter and accordingly we are getting our current which in terms of milliampere. The last one is your controller. Controller means we are giving error in terms of voltage and correction we are getting in terms of output which is also in terms of voltage. So these are the different types of component which is represented in terms of block diagram. So next we will discuss regarding transfer functions. So what is transfer function? Transfer function basically we are taking Laplace transformation of input to the Laplace transformation of output keeping initial condition is equal to 0. So here also we can discuss transfer function is the ratio of output to the input of a control system component and that can be generally is a function of time as well as frequency. So here we have represented Z is the gain we are giving input signal as A and getting output signal as B. So here we can get the gain value which will be equal to output by input. So here it is written as B by A. It is the output by input signal Here also we are considering the angle value. B corresponding angle is beta, A corresponding angle is alpha. So we can write B by A as it is divided, so angle will be subtracted. So it will be beta minus alpha. So it considers the phase shift which is related to the time delay also. Next we will discuss regarding open loop control systems. So open loop means, always remember, it has only feed forward path. It will be from input to the output side. We do not have any access from output to the input side. Also it doesn't have any feedback loop or feedback path. So open loop modify output based on the predetermined control value. There is no actual measurement of control quantity. So here we have taken one image. So what is that? This is same water tank and taps are there. Here water is coming from the tap which is represented by Q in. It is coming to our tank. Here final element controller is there with the help of valve and Q output is there. So whether we require water or not, it will be taken decision by the controller. So here only we do have access which will be from input to output side, and there will be no access from output to the input side. So controller means there will be the valve setting positions. So here there are elements, sub element for a open loop control systems. What are they? One is controller, one is valve setting, then it is coming to the control valve. Here we are getting output flow, it is coming to the tank, then tank level, water level will be shown. So this is from input to output side only. So here we can also consider there will be disturbances or not. Tank level may be vary with outside disturbances and system changes. Next one, open loop control system modifies the output based on the predetermined control values. There is no actual measurement of the control quantity basically. Next, we will discuss regarding closed loop control systems. From the name, you can understand that closed means we do have access from input to the output side, which is known as feed forward path. Again, there will be access from output to the input side, that will be called as feedback path. So closed loop basically consists of forward path as well as feedback path, which is closed one. So we have taken same example for previous one. We can see here. Just a minute. Here we are having reference or reference values or setting points. Then it is connected to the controller. Then it is coming to the control valve and tank. So each point will be decide the value of setting, output flow or desired value. So reference point means this is the desired value which is represented by positive sign. Then controller, again it is coming to the valve setting. Whether control valve will be opened or not, how much percentage it will be taken. Then output flow means this is the flow of water which is coming out from the tank, that will be taken. Okay, so next one, here we can see that, just a minute. Here we can say that there will be flow of water, mechanical power, disturbances, actual speed. So we can also consider for automatic cruise control system whether it is coming downhill or uphill, or it will be headwind or tailwind. So that can be also controlled by the help of automatic cruise control systems. So generalized block diagram for our closed loop control systems will be, so here this is the reference point. Here we are having feed forward path that can be represented by the gain, which will be equal to C by E. C is the output. Here measurement means this is H, which is represented by basically H will be equal to Cm. Cm means measured value by C means this is our control variable. Here all terms are written. We can say that R for reference point, E for error, and control variable which is represented by C, and measured variable which is represented by Cm. So we can see that the error will be calculated, the difference between actual value and measured value. Again, it is coming from output side to the input side. It is written as E, which will be equal to R minus Cm. So the main merits of a closed loop control system, we can reduce the error by following number of loops. So E can be reduced 0 when reference will be equal to measured values. So lastly, we will discuss regarding difference between open loop and closed loop control systems. Previously, we have taken so many examples, fan with regulator, without regulator. Now we also discuss regarding our irons. Nowadays we are using automatic irons. It will sense the temperature, whether it will be required or not. According requirement, it will adjust itself. Then so many examples like toaster, AC. Now we will discuss what are the merits, demerits between open loop and closed loop control systems. Basically, open loop is inaccurate. Second one, closed loop is accurate. Open loop is unreliable, but closed loop, always remember, it is reliable. Second one, next one is your open loop is stable and it is unstable, and it can be stabilized using feedback or any reducing sensitivity. Next, in open loop, bandwidth is small but it is large in case of closed loop control systems. Next, open loop is easily affected by noise, but closed loop, always remember, it is less affected by the noise. Next one, open loop, as number of control parameters is less, so it will be cheap and costly. So next one, open loop is simple in construction, but closed loop is complex in construction. Next, open loop is require less maintenance, but it requires more maintenance. Always remember, overall gain of open loop control system is high, but overall high gain is reduced due to the presence of feedback in closed loop control systems. So here in this class only we have discussed regarding what is systems, what is control systems, what is open loop control systems, and what is closed loop control systems. Again, we have differentiated between open loop and closed loop control systems. In next class, we will do some problems related to the open loop and closed loop control systems, and we will do some mathematical derivation and block diagram reduction depending upon this analysis. Thank you everyone.